Oh, recording, right? And maybe last time I did a mistake, or so I put you. I tried to put you all as a host. Maybe just by human error, someone clicked on stop recording, so it didn't went. But it is recorded, and then at the evening of the same day, I will try to upload it to YouTube so that you can watch it even if you are not logged into the university system. Okay, so well, is as follows. I want to open MATLAB here on the podium and just show a couple of tricks or just basic use. And we want to cover several aspects of using it at the basic level. We are not in the math or programming class. And so here is a tentative list. So which we will set up as a subjects for presentations, right? Like for credit towards your grade in maybe a couple of weeks, right? And the skills of using the software will be used towards practicing actual physical chemistry, as we discussed last time. The writing equations is boring. Experiments are expensive, and class is short. So we do need to do something reasonable, which we can do it at short time. And by using of this, how to say, suite of software, we will run little codes that will model our goals and do the projects. Oh, okay. I can imagine that pens can talk to people, but I never saw it.
Yeah, it's a live scribe pen. So
okay. Oh, okay. Okay, that's cool. Hi, how are you? So what we are going to cover, or at least to try to cover, let me focus on the screen. So it will be much more interesting when we do practical things, but the complex numbers, functions using MATLAB as calculator, basic calculus like derivatives, integrals, vectors, and matrices, then for my curiosity, may I ask who is scared of this word and who is happy of this word? Like eigenvalue problem, are you like, it's your most natural thing to do, you hate and do not know what it is, or you heard something, but you would like to hear more? Oh. Okay, okay. Well, I don't believe you never heard about it. So some people in class are exaggerating their impression of this word. Huh? Oh, okay. It's not my word. it's math terminology. So basically, everything we are going to do in this class, with or without MATLAB, in this like 2 months of the PChem, is related to eigenvalue problem in the very narrow sense. Our first part of physical chemistry is quantum mechanics, right? And in narrow sense, quantum mechanics is application of eigenvalue problem to natural objects like atoms and molecules. Maybe just before going to, it's much easier lecturing rather than doing practical things. So I'll use a couple of minutes telling, since you guys wanted to hear. Let me bring an empty slide and just do some writings there. works at least this way. So when we are dealing with differential equations, some typically, so differential equations means the set of derivatives applied to unknown functions, right? And these typical algebraic equations give us numbers as answer. Differential equations give us functions as answers. And in between algebraic equations and differential equations, there are matrix equations. Like the simplest matrix equation when you multiply matrix by vector and get another vector, right? But there is a situation when one is acting by a matrix. Like I'm doing just 2 by 2 matrix on the vector, and one is getting the same vector. So with maybe a numerical factor. So if these numbers A, B, C, D are known, and this vector, which can be 2-dimensional or 100-dimensional, is unknown. So equation to find such vector, such set of numbers that satisfy this equation is called eigenvalue problem. And I'm a little bit exaggerating, but in a narrow sense, all quantum mechanics is reduced to solving such problems. Solving them by pen and paper is boring and impossible for matrices more bigger than 3 by 3, right? For humans. For computers, it doesn't matter. One can do like 10,000 by 10,000. So in some sense, we will, as humans, we will formulate problems of physical chemistry, reduce the problem into a matrix, and then ask MATLAB to diagonalize a matrix. Diagonalize means find eigenvalue. So those are two like identical words. And the learning of the MATLAB skills is a big shortcut. Like if you would get similar course like 50 years ago, it would be definitely like a lot of homeworks with diagonalizing matrices, no matter who is instructor. Now we can skip it and let computers solve problems for us. And what we are going to do in this class is not the first principle ab initio. It's not computational chemistry. It's just MATLAB assists us to diagonalize matrices. And this will be most important skill in using this software. So visualize, well, everything can be visualized. As we go through this short course, we will need to plot some functions, and MATLAB will be assisting us. If we plan to educate ourselves, not for education, but for achievements, if you want to finally write reports, and some of you may wish to use it as a seeds for your actual research, there are rules of game which you probably know, that if you do some graphical information for publication, it should be high quality, like, and everything should be not artistically beautiful, but very recognizable, like big fonts, thick lines. And the MATLAB is alternative software to making figures. So we will also going to cover it. Some processes develop in time, right? And time development can be visualized by movies, right? So we are going to do it as well. And last two things are just basic skills of minimalistic approach to programming. So in the given time, there is no chance to become professional programmers for hire, but if we get some pre-written codes, we can intelligently modify them. And we need to get some basic ideas what and how to modify. Okay. So Okay. And I'm going to do the same thing as so I can try speaking about how to install, but did you got MATLAB on your? Okay. Did you got help? Did they promise to help? Okay. But as soon as you are registered NDCU student, you have privileges to install it for free. And there is an alternative way to get it online through CCast computer, and maybe I'll show it later. We better go to our main part. And good, good. So when you do have, you open the okay, I think this font should be a little better and visible on the common screen, right? So you see it, right? So the thing here is so-called command line. So you do have interface to, well, not literally to computer, to this software. And basically it's same as you chat with your friends. So you type something and computer answers you something to you. I don't know if it will answer something reasonable if you ask things by human language. Yeah, so it doesn't, but it does recognize the mathematical symbols, right? So please just try to use it as math and ask it something which you can reproduce as humans or which you cannot reproduce as humans. Let's check what was our plan. Oh, complex numbers. Okay. So before we go to complex numbers, please try to type pi. And check if it does recognizes you. So the three trigonometric functions are included. So it's same like your calculator, right? It recognizes the pi number, and you see here is like 1 to the power minus 16. It is as good as 0, right? So it's like numerical 0. So let me walk through the tables and see that you feel comfortable in these things. Okay, good.
Can't change my brightness, but I got.
Yeah, I see. Yeah, thank you. So let me ask you about your impression about the concept of complex numbers. So I'm curious to hear if the concept of complex numbers is something you really like and use every day, something you hate, something you never heard, or you've heard something and you want to hear more. So complex numbers. So you know what they are, but you hate them, right? Okay. So let's just do a little interview. It will be so. What can you tell about complex numbers? What are they? Just between us.
I don't remember a whole lot about complex numbers.
Just something.
They're very difficult to work with.
Okay, but is there an example of a complex number?
Like a negative, I don't remember the eyes.
Yes, eyes. Yeah. Typically, very good. Yeah, they use the yes, imaginary and the symbol I for complex number. Yes, yeah. So, what is I?
Square root of -1.
Okay. So, I'm in a presence of educated people. Anything about complex numbers? Who need them?
Who need them?
Yeah.
Who need the complex number?
Who needs complex numbers?
Okay, physical chemists.
Okay, good. Anyone else?
Engineer.
Yeah. Which engineering?
Mechanical engineer.
How about electrical engineering? Okay. Okay. For what? Which part of electrical engineering needs complex numbers?
Circuit, electrical.
Circuit signal processing. Yeah, very good. So these 3 participants answered all my questions. I need to design more. Is there any connection between trigonometric functions and complex numbers?
You can use matrices to help.
Okay.
Use imaginary numbers in matrices that
Okay.
could help explain what
Okay.
you're looking
Okay.
for.
Yeah. Nothing is wrong. All is correct. Any other benefits? Any connection between trigonometric functions like sines and cosines and complex numbers?
They can be connected through they're both used in math.
It's absolutely correct. I cannot argue. But how they are connected?
They are things used in math.
You are experienced in rhetorics. You know how to answer questions. But so is there any connection between trigonometric functions and complex numbers?
The Euler identity.
Yep, absolutely correct. Is anyone follows what Lola wants to teach us?
Euler identity.
Excellent, excellent. Will you come to the board and try to write it? It will be a great help to all of us. Come on. No. Just write an equation for Euler identity. And do not fear. No one knew what it is, so you can write something wrong. No one will find it. So what I'm just playing with camera and trying to focus it on your board, so that. Actual physical chemistry is much easier than operating this camera. Okay. You're doing everything correct. Yes. So does anyone recognize this equation more or less? Okay. So yes, and it should be equal to something. To equals to. No. Let's solve it together. So I'm really happy to see this circle. So Lola did draw a circle with two axes, right? And there are sine and cosine, which from our high school we know that cosine will be x projection of a vector, and sine will be y projection of a vector, right? Now, what is the radius of this circle? Just one. If typically it's, yeah. If it is not one, then the projections will be r times cosine, r times sine, right? Okay. And this point, or the tip of a vector, is parameterized by two numbers, right? X and y projections. But we know that it is like a tip on a line, and it is at the same time it's parameterized by a single number, just by angle. So is there a way to summarize this both x and y projections in one number, in one symbol? So complex numbers is just combination of two projections into one number. So one can call that this is like x, this is y times I, and this equals to z. Just write letter z. And if we are doing this complex number on a circle, if it is really sine and cosine, then just by it's defined that it will be exponential to the power I theta. Can you write it down? E I theta. So it is a notation. So if we use exponential in the complex power with a complex number, then it is expands into summation of sine and cosine. Yeah, thank you, Lola. It's really great. Yeah, thank you. Hamid, did you wanted to add anything just by saying or writing? Okay, yeah, thank you. Okay. Let's return back to the instructor camera. Okay, so I did learn from you two things. One, that the most popular complex number is I, right? That I is square root of minus one, right? And that complex numbers can replace or help to process trigonometric functions. Trigonometric functions needs when something is oscillating. Therefore, it is used in electrical engineering signal processing, right? In quantum mechanics, there will be like oscillations of electrons. If they are excited, and even if they're not excited, if they're sitting in the molecule, they do some quick oscillations which will need this complex functions. So let's try a little exercise here. Oh, another story. It looks like I'm trying to escape actual teaching and just telling stories. If someone believes in like evolution and development of human society from simpler forms to more advanced forms, which some people agree, some people disagree, then on this intellectual progress, there are several steps. And at the lower level, people were counting objects like apples, and they are natural numbers, right? Starting from 1, 2, 3. Then people started removing goods from each other, subtracting. And operation of subtraction brought in integer numbers with negative, like 0, -1, -2. Then people started chopping things on pieces. And then it brought rational numbers. So operation of division brings in fractional numbers. And then, so this was until medieval times and everyone was happy. But then I cannot give exactly the number, but approximately at the time before Galileo, so he was just summarizing like 1,600 people. Well, maybe before, but it was coming more and more to public discussion. People were designing ancient catapults for military activity, and then cannons. And when there was applied problem of hitting a target by projectile on big distances, one realized that the projectile is developing not on a straight line, but on the arc. And if one wants to predict like where the projectile will land, one needs to solve so-called quadratic equation, polynomial equation. And when we solve quadratic polynomial equations, there is an operation of square root, right, for finding determinant. So when we were taking quadratic equations in like mid school and high school, there were rules. If this discriminant is smaller than 0, then there are no solutions, right? If one needs to take a square root of negative number, right? But human curiosity was prompting that as far as we bring more operations, they can be done with new class of numbers. Like fractional numbers were designed only after bringing division operator. If you bring in operation of square root, we come into complex numbers. So yes, QRT stands for square root. If you have like 4, the answer will be 2. If square root of 1 will be 1. Right? And if you put minus, then it gives the 2 components. First component is 0, so real projection is 0, imaginary is 1. And the MATLAB happily recognizes this complex numbers. So one can just try, let's try I to the power 2 minus 1. So it recognizes what is I. And if we do exponential of I, I times pi, then it shows this -1 in real and 0 in imaginary. Let's check if Lola taught us well. So according to Euler and his representative Lola, the exponential of imaginary angle must be equal to cosine of the same angle. Let's try cosine pi minus 1. So Euler and Lower at least are half correct, right? So exponential of angle pi will give -1 for real part, right? And let's check for imaginary part. So if you do sine of the same language, not only same, it gives 0, right? So 10 to the minus 16, we must believe that it is 0, right? It's numerical 0. So I times 0. So thank you, Euler. Thank you, Euler. This right now it is not. We shouldn't have a lecture, but this Euler equation is really, really helpful in many things, and it's hard for me to control myself and not to tell the story. But I don't know about you, but I was suffering in high school of trigonometric identities. It was requested to memorize them and do exercises, and it was so unlogical. It's so much memorization, same as in biology, like senseless effort. And these complex numbers, there is a trick, there is a hint how to derive all trigonometric equations in one line. I'll just skip this pleasure for later because we need to do MATLAB. But it was kind of my revenge. I thought everyone wasted so long time, and now it can be done quicker. Let me look on my cheat sheet, what we should do next. Okay. Functions, definitions of argument. I'm substantially slower than I was thinking, but I'll try to speed up. And in a couple of weeks, we will need to make a session when we will split this subjects between all attendees of the class. You will come to the podium and briefly summarize the skill. It is most efficient way so that after this meeting, everyone can operate MATLAB more or less efficiently. So functions, definitions of argument. One can define variables like x equals 2, y equals x squared, and it immediately follows this equation. But this is like kindergarten. We will need functions, right? Or we need to repeat the same operation several times for different values. As when you run experimental tools, it records the data in a CVS format in Excel, and then you plot it, right? If you do experiment, if you do theory, naturally get numbers, but typically everything natural science is dealing are dependencies, right? Something is argument, something is function. So instead of setting up the argument as one number, one can do like 2 numbers, or one can do like 10 numbers. But one needs spaces. And then if one types the same thing, y x squared, then it automatically computes the function, makes the progression, right? And right now we are using some simple example, but the same thing can be done in a better format. So one can, to save human time and typing, just progression from 1 to 10. Okay? And we are not restricted by natural numbers. We can do like fractional from 1 to 10 with step 0.1. And then it goes by little increments, right? So what is most natural thing? And if you do not want garbage on the screen, we can do just semicolon at the end. So if you just plot, then it shows a line which is just a set of these numbers, right? But one can define a function, and then by several points, by several numbers, when it represents mathematical function, right? Okay. Let me walk around and see if everyone is happy and doing similar exercises. If you have any difficulties, I'll just stop by and try to help. But you didn't define x yet. You need to like type x equals enter, and now yeah, x comma x period, symbol of power. Yeah, close the bracket.
And it should pop it up. There.
Okay, excellent. Yeah, thank you. Okay. Yeah, and try to plot x comma and then add the x squared. X point, x point, symbol of power, shift 6, 2, close the bracket, enter, and alt tab to navigate to the right. Okay.
Thank you.
Yeah, thank you. X point, symbol of power, shift 6. Close the bracket. Do you have more than one Windows figures? Oh, there is an extra point, x to the power 2. If you do x to the power 0.2, it's almost x to the power. It will be different slope. No. Keep period before symbol of power, but delete period before 2. Period, this remove here, and put between x and no, comma, skip. No. Yeah. Now I'm surprised. Everyone
Is
is.
it in my X?
Let me.
I reran it. X is.
Oh, okay.
Yeah. Oh, it needs to be a colon, not a semicolon. That's why. There we go.
Haley, did you get this problem? Okay. Yeah. Thank you. Yeah. Great. Yes. Symbols. You can let me show it for everyone. So suppose we are doing big science and we are studying different functions like x squared and x, I don't have much imagination, x to the 3rd power. You see, there are 2 lines. And sometimes we need more than two, like 10 lines. And in order to see their difference and to appeal to audience or to reviewers, we need to, like, using different colors works if there are like 3 lines. If there are 20, whoever reads our work will tell, I'm colorblind, I decline to read it and I reject this paper. We do not need to give reviewers this chance, and therefore there are some tricks. So one can do, for example, dashes, and then one can tell, we compare solid and dashed line, right? And if there are really many of objects, one can use symbols like star. So stars versus dashes, or circles versus dashes. So you after argument and function, you put another comma and tell what is the style of line and symbol. And there are additional keywords to change the thickness and color. Like if you do nothing, it automatically does rainbow pattern for lines. But if there are too many, it doesn't help. And there is a way to manually operate them. Oh, does it answer your question?
This part, after that I lost.
Oh, you just type plot, bracket, x, no, rectangle, not rectangular, round, x, comma, y, close bracket, enter. And there appears a figure. Okay. Okay. So let me look on my cheat sheet. So we are done with complex numbers, functions, basic graphics, derivative infinite differences. Yeah. So revisiting calculus. Yeah, everyone is so excited. So suppose I am defining y equals x to the power squared. By the way, the period here tells it is a command to MATLAB. Forget about linear algebra. It instructs MATLAB to forget about linear algebra and take numbers in the array just as numbers. If you do not do this period symbol, MATLAB will think that it is so smart and will try to apply linear algebra rules, which are where you like there are row vectors, column vectors, and it will try to follow them. We'll do it soon as well, maybe not today. So period is to stay with just regular calculus like processing of functions. So we did define a function, and here is a killer question: what is the derivative of x squared? Okay, so it will be linear, right? And another killer question: what is the derivative of x? Okay, so we are on the same boat. Now let's check if MATLAB can do the same. There is, if you were installing the full version, there is a symbolic math toolbox, which we do not need. We are doing just numerical processing. And right now, we as NDCU employees, we have access to all toolboxes. But if you would purchase privately, you saw there are like 100 toolboxes, and each of them charges noticeably. So, but for most of things, one needs just basic MATLAB. It's already very powerful. Okay, so there is a function diff. So let me apply it before this big function just to progression. 1, 2, 3, 4, 5. So this DIFF subtracts neighbors and give their values, right? Make sense? So if there is a progression of numbers which are spaced equally, you just write spacing between numbers. And here the spacing is equal. If we do, I'm just giving by hand. If you have progression of numbers which are spaced not equally, start from 0. You see here in this progression spacing increases, right? And then it shows that spacing becomes bigger, bigger, and bigger, right? Everyone is happy with it, right? So the progression of 0, 1, 4, 9, 16, 25 is like x squared, right? Correct? And here we see linear increase of spacing, which is a kind of derivative of square function. If we do the same thing for if our and we want to divide it by spacing between argument. See what happens. So we took quadratic function, we applied this derivative and divided by dx, by increment between them. And you see it goes up linearly. The x axis right now, just number of grid points, but if you want it to be more reasonable, you can do so as x goes from 0 to 10, or like when x is 1, the derivative is 2. So your hypothesis about derivative of x squared will be 2x is correct, right? So please practice it, and I'll go around and see that you see it. And you don't need to do this simple functions. If it is boring, you can do something more advanced. Space 0. Space 0. Close rectangular bracket, close round bracket. And then round. Enter. And Alt tab to navigate to right window. Or with mouse, yeah, bring. Yeah, so you converted parabola into linear function by this differentiation. Yep. So you may be curious about this little 0. So if I scroll back, when we apply this operation to a string of 1, 2, 3, 4, 5 numbers, we get the answer of 1, 2, 3, 4 numbers. So the length of a string is one item less. And in order to plot figures, functions, we need to have the equal number of x and y points. So there is a mismatch of number of points. For x, it is more, for diff, it is less. And then we enclose it in a rectangular bracket and add a dummy point, which means nothing but keeps the format. Oh, you're writing a manual. Okay, is there a figure? Thank you. Okay, yeah, that's great. Thank you. Yes? You started from 1, but you can start from 0 when defining x. Scroll up by click here and arrow up. And go to the where you define x. Yeah. We have about 5 minutes left, right? We are until 15 or until 30. Okay, yeah, then we have freedom to do a lot of things. Okay, so we need to do, we did differences, finite differences, and we haven't done integration by sum. What is integral?
The inverse of a derivative.
Yes, correct. And what is the, is there geometric visual definition of integral?
Rectangular parts or something?
Okay.
The sum of the pieces, like rectangular parts of a function.
Yeah, that's correct. And any other visual definitions of integral?
Area under a curve. Sorry.
First place is shared. Right, area under a curve. So if you have a curve,
it is the next higher dimension of a function.
I hear a voice from above. Nice to hear from you. Can you please repeat? I was so shocked that I didn't realize what you're telling.
An integral is the next higher dimension of a function. So a line becomes an area, and an area becomes a volume.
Yes,
So
one can say so. Yes.
a more general statement than area of a curve.
But area is a number, and function has many dimensions. So in some sense, one can tell also the dimension is reduced. So from a function, you get a number. But thank you for bringing in this discussion. Both are correct. So we set up limits of integration, initial and final. And we cover the area under the curve, right? So suppose we are not humans but robots. We are robots. Then and we are simple robots that do not know analytical functions. We process everything with numbers. How to represent, how to implement concept of integration on simple operations with grid points? Like if the function is set of values, set of numbers, not a continuous function, but same as we did before, like number here, number there, number there. How do we implement the concept of this area? Just repeat what you've told before
The sum of the rectangular or trapezoidal pieces added together.
Yep, thank you. Makes sense for everyone, right? So if the function is set of points, one can just look for this little rectangular elements and add them together. And each element is a value of function in point like 1, value of function in point x1 plus delta x, if they're equally spaced, and then it is multiplied by delta x. Right? So basically, integral is a summation of all values, and then it is multiplied by delta x. So instead of infinitesimal dx, we have a finite delta x, which is an offset between numbers. So the answer of this procedure will be one number, not a function. If we need integral as a function, then we need to continuously explore different upper limit. But for definite integral, it will be only a number. So let's take our x function and suppose we have simple operation of guess what it gives. So we have a string of several numbers and it just adds them together, right? What if we have ramping increasing numbers? Is it correct? So it just adds all of them together. And by the way, this trick will work only for small offset delta x. If delta x is big, then it will give very wrong results. Now let's try to apply this one to our sum of x, which so our x goes from 0 to 10, right? And our offset is 0.1. Now let's check just as regular humans, what would be the integral of x dx from 0 to 10. So x squared over 2, right? And we need to explore it at 0 and 10. So it will be 100 divided by 2, it will be 50. And we get 50.5 because numerical error. If you make the offset smaller, then the result will be more and more correct. I think it's quite easy exercise, but please try doing it. I just want to make sure that everyone feels comfortable. Okay. Can you please push arrow up? It will bring the arrow up. It will bring the history, and x goes from 0 to 10.1. Oh, you are integral. Not plus, multiply. You need to multiply. Not plus, but multiply.
Oh. Okay, so not to multiply. Oh, the
Star.
Sorry, I have really bad eyesight.
Okay, yeah, excellent. Thank you. But if you want to do a smaller step, you need also to redefine X, right? And now your step was 0.1. It should be consistent. One can, if one wants to do this exercise in a more consistent way, so arrow up brings up what was typed before. So if I want, I can put here dx, and before I do it, I need to define like dx equals 0.01, like 10 times smaller. Then I define new x, which will be very big. I don't want to show it. And then for this summation, I instead of 0.1, I multiply by dx. And you see the error becomes smaller. From 0.5 it's 0.05. Okay.
So this is the part of the integration, right?
Mhm.
And you defined yours as 0.01.
Yes, the idea of integration that one can do smaller and smaller steps, and then the result will be more and more precise.
So you could change the value of dx.
And simultaneously, I need to change the offset. I need to redefine how x goes, the offset between points.
That's between the
Yes. Okay, great. Yeah, thank you. Okay, let me open the cheat sheet. So we've done integration by summation. Vectors in MATLAB, scalar versus, okay, vectors in MATLAB. Okay, we have 9 minutes. We will start vectors. How happy or unhappy you are with dot product? Everyone is happy with dot product? Yes, no, heard about it but not happy. Can you tell us something about dot product? It's not there, just from your memory.
Oh, dot product.
Uh-huh.
No, I don't remember.
Okay, that's okay. Scalar product doesn't good.
The addition of scalar vectors. I don't know.
Multiplication.
Multiplication of vectors.
Okay.
Okay.
Dot product.
I think, well, I know it's multiplying to, I don't know if it's vectors in this case.
Yes, yes.
So,
So
with the absolute value bars next to them also.
Something. Well, you can do it without. Sometimes there is a dot between them, therefore it's dot product. Dot product, scalar product.
I have no idea.
Your interview, CNN interview about scalar product.
It's multiplying two sequences of numbers.
Absolutely correct. You know how to formulate things. What? Dot product.
I don't remember.
You do. You are just trying to hide your knowledge. Hamid, please us by something about dot product.
I just know the formula that A dot B is like A and like B and then cos theta, I guess.
Okay. Oh, we need to deliver a pen to you so that you do it on a board. Okay. Yep.
This is the absolute value for A. This is the absolute
And can you do it geometrically, or like geometrical interpretation? Visual. You do. You guys are all so humble. You hide your knowledge. I'm confident you know these all things. Okay. So what will be the dot product of two vectors that are perpendicular to each other? What is the cosine of 90 degrees of pi over 2? Cosine of 0 is 1, and cosine of pi over 2, cosine of 90 degrees. So dot product of two orthogonal vectors will be 0. Yes, correct. But you did everything good. You saved the class. Yeah, thank you, thank you, Hamid. So if we live on geometry and geometrical interpretation, then I'm spending most of the class time just navigating this camera. I was very spoiled in previous university when I was teaching. There was in each class there were tech support on the back seat who was like operating and following the instructor. So I'm just trying to learn a lesson from Hamid. So if there are two vectors, A and B, the scalar product is projection of one vector into another. So it's like B length of B times cosine of angle between them will be this projection. And then you multiply this projection by length of vector A. If the vectors are parallel, then this dot product will be just product of their length, right? If they are orthogonal, then dot product will be 0, right? Because of the cosine. Now, what if our A vector is composed of two components, AX, AY, and B vector is composed of two projections, BX and BY? Can we set up the operation of dot product not in the geometric, but in more algebraic, in the matrix form, based on projections? So if one defines dot product as a product of each projection adding together product of another projection, A, Y, B, Y, then this mathematical operation will give the same result as the formula with cosines and that we interpreted visually. Let's just check. So if A is parallel to B, which, for example, A equals 1, 0, B equals, let's do it creatively, 2, 0. This formula will tell that length 1, length 2, result will be 2, right? Here, this equation will give us X projection will be 1, Y projection of B will be 2, plus 0 times 0 equals 0, same result, right? Now, situation number 2. A is orthogonal to B. Let's set A equals 1, 0, B equals 0, 1. Bless you, bless you, bless you. So we define A dot product B will be 1 times 0 plus 0 times 1 will be 0. Same result as here, right? So dot product is defined as a sum of products of each projection. Right now, we covered the only two-dimensional situation. And let's practice it on MATLAB first to see connection with what we did. So where's the MATLAB? So I can define A equals 1, 0, B equals 0, 1. And then I type A times B. It gives 0. So note a little trick. For A, I did row. For B, I did a column. Just try to repeat the thing, and then we either finish or I will add some brief comment. Try to use rectangular brackets. Enter. Now B equals open rectangular bracket 0. Now enter, hit enter. Now type 1. Now close rectangular bracket. Close rectangular bracket. Enter. Not minus, but equals. Enter 1. Close. Enter. And now type A times B. Okay, good. A times B.
A times B was 1. And I'm just going to try another.
Okay. Try to make them orthogonal, like 0 and something. B equals 0. Enter. And now type. You see?
Yeah.
Yeah, thank you. Okay. Okay. Did you say? Okay. Yeah. Thank you. No space between 0 space 1, or if you want to make it vector, column vector, enter, type enter. Now type 1, 1, 1, and close rectangular bracket, enter. And now type A times B. Okay, good. You got it. Yeah, yeah. So I would be really excited to chat for hours, but probably you have other things scheduled. So let's try to be organized and finish now. But we have started vectors, and we got basic idea about dot product. We'll continue on it next time. And what is also important is that vectors can be written as rows or column, and a result of mathematical operation, both in our theory humans and both in MATLAB, may depend on whether it is row or column. This is an important mathematical concept used in linear algebra in MATLAB and later on in quantum mechanics and physical chemistry. So let me suggest finish the meeting. Everyone is welcome to disconnect and depart. I'll stay here and answer questions if any. Okay, thank you. On Monday, I will deliver more academic lecture, and next Wednesday we will do a MATLAB session again.